Welcome to This Explainer. Okay, today we are diving into a literally chilling new geological discovery about the U.S. West Coast. For decades, scientists, emergency planners, and practically everyone living along the Pacific coast have been bracing for this massive seismic event. But what we're unpacking today suggests that everything we've been prepping for, it might need a serious, dramatic recalibration. Through the evidence we're going to look at, we'll uncover this hidden mechanism deep beneath the ocean floor, and it points to a synchronized mega disaster, something that could completely redefine how we understand seismic risks in North America. Let's get into it.
So for years, the ultimate nightmare scenario for the Pacific Northwest has been universally dubbed the Big One, right? We are so used to hearing about the Cascadia subduction zone and the absolutely catastrophic event it's capable of unleashing. I mean, it is the benchmark for all disaster planning in that region. But what if the Big One actually isn't the worst-case scenario? What if the very parameters of our worst fears are just too narrow? Now, this isn't just some hypothetical question I'm throwing out there. This comes directly from Chris Goldfinger. He's a marine geologist at Oregon State University and the lead author of a really groundbreaking new study. And his conclusion is pretty stark. He says it turns out it's not the worst-case scenario. Think about that. When the lead marine geologist studying the Cascadia subduction zone tells you that the Big One isn't actually the ceiling for disaster, well, we absolutely need to pay close attention to what exactly is. Look, we already know a single powerful earthquake can completely wreck coastal infrastructure. We're talking entire roadways sheared right off, vital supply lines entirely severed, and coastal communities left completely isolated. It's devastating. But the new evidence we're analyzing today suggests the next major event might not be isolated to just one region or a single fault line. Instead, we are looking at the potential for a multi-city disaster, one that unfolds all at once, in rapid succession, possibly even within minutes. That level of severe damage could be multiplied across the entire western seaboard simultaneously. Section 1, a fortunate navigation error. So to really understand this immense threat, we kind of have to go back to a seemingly minor mistake at sea. Picture this, it's 1999, and Chris Goldfinger and his team are out on a research cruise. Their goal was to collect sediment cores from the Cascadia subduction zone off the coast of Oregon and Northern California. But things didn't exactly go to plan. The team actually drifted off course. They ended up roughly 55 miles south of Cape Mendocino in California. This little navigational error pushed them right out of their target zone and straight into the territory of the San Andreas Fault Zone. But, instead of just packing it all up and heading back, the researchers made this incredibly serendipitous decision. They decided, hey, let's just collect a core sample from the ocean floor right here anyway. Now, to understand what they actually pulled up from the depths, we need to quickly define a crucial term, and that is turbidites. Turbidites are essentially these layers of sediment left behind by underwater landslides. When a massive earthquake strikes, it violently shakes the continental margin, and that triggers these huge underwater landslides. All that debris flows down into the deep ocean and eventually settles into distinct layers of mud and sand. For geologists, these layers are absolutely pure gold. They're literally the physical fingerprints of past earthquakes. The absolutely crucial number to keep in mind here is 3,100. Because by pulling up these deep-sea mud cores, the researchers aren't just looking at dirt, right? They are looking at a literal geological time machine. These ocean floor cores preserve roughly 3,100 years of geological history. By carefully looking at the sequence and the structure of these turbidite layers, scientists can basically read the history of earthquakes in that region, stretching back over 3 entire millennia. And well, that brings us to what they found in that accidental 1999 core sample. Under normal conditions, physics dictates a very consistent pattern for these turbidites. The heavy, coarse material from the landslide, that settles out of the water first, dropping straight to the bottom. Then the lighter, finer sediment slowly settles down on top of it. That's your standard, everyday signature. But the 1999 discovery showed a completely reversed pattern. No joke, they found fine, silty sediment on the bottom, with coarse, sandy materials sitting right on top of it. This was a highly unusual structure, and it completely defied the normal settling process of a single underwater landslide. Section 2, the doublet phenomenon. Okay, so that strange anomaly in a mud, it wasn't just some weird quirk of ocean currents. It actually points to a 2-step back-to-back rupture connecting the West Coast's 2 most dangerous fault systems. It's like a geological 1-2 punch. Step 1, a major earthquake strikes the Cascadia subduction zone, shaking the whole region and creating that lower, finer layer of sediment. But then, Step 2, the nearby San Andreas Fault triggers shortly after, literally subsequent to the first event, causing another underwater disturbance that dumps fresh, coarser material right on top of that still settling fine layer. Activity on one fault basically seems to have triggered the other. The faults, it turns out, can actually sync up. Of course, in science, you don't just rely on one random core sample. So to confirm this totally mind-bending idea, the team collected more cores near Cape Mendocino, which is the exact area where these two massive fault systems meet. They ran precise radiocarbon dating on these samples, and the results were just stunning. The dating confirmed that these layers, which researchers are now calling doublets, they weren't just random aftershocks or unrelated geological events. No, they were massive, independent earthquakes happening really close together in time. In fact, Goldfinger noted 3 specific cases within the past 1,500 years, including the most recent one back in the year 1700, where the data suggests these synchronized quakes happened within minutes to hours of each other. Minutes to hours. Now, you might be wondering, has anything like this ever actually been observed in modern history? Well, while real-world evidence of major fault lines interacting this way is incredibly scarce, there is a documented precedent. Over in Sumatra, 2 massive, devastating earthquakes struck just 3 months apart in 2004 and 2005. So this whole concept of massive, adjacent fault lines triggering one another in a really compressed time frame, it's not science fiction. It is a fully documented geological reality. Section 3. A multi-city mega disaster. So we really need to take this deep-sea geological evidence and apply it to the surface, where, millions of people live today. If the Cascadia subduction zone and the northern San Andreas Fault synchronize again, the geographic scale of the destruction is almost hard to even wrap your head around. We are talking about simultaneous emergency zones encompassing San Francisco, Portland, Seattle, and Vancouver, all at once. Instead of one massive quake hitting the Pacific Northwest or one massive quake hitting Northern California, multiple major metropolitan regions could be thrust into a state of total devastation at nearly the exact same time. To truly grasp why this matters so much, we have to return to Chris Goldfinger. He outlines the stark, literal, logistical nightmare of this synchronization. He says we could expect that an earthquake on one of the faults alone would draw down the resources of the whole country to respond to it. And if they both went off together, then you've got potentially San Francisco, Portland, Seattle, and Vancouver, all in an emergency situation in a compressed time frame. I mean, just think about it. The sheer volume of medical aid, search and rescue teams, food, water, and infrastructure appear required for just one of these cities is completely staggering. To multiply that across the entire West Coast simultaneously, that would stretch national and global relief efforts absolutely beyond their limits. Which leaves us with a final, absolutely vital question. Is our National Disaster Recovery Plan actually ready for a synchronized megaquake? For decades, our preparation has been entirely based on this idea of an isolated Big One. But those turbidites hidden deep beneath the ocean floor, they've revealed a very different, much darker historical pattern. The Earth has literally shown us that these two giants, Cascadia and San Andreas, can wake up together. The science is now telling us what's possible. The question we have to answer now is whether we're truly prepared for it. Thank you so much for joining me for this explainer. I really hope it brought some critical clarity to this deeply important topic. Keep learning and stay curious.